Hello, Geosley. How can I assist you today?
Hey buddy, will AI replace software testing?
The question of whether AI will replace software testing. While AI has the potential to automate certain aspects of software testing, it is unlikely to completely replace the need for human testers. AI can assist testers by automating repetitive tasks, analyzing large amounts of data, and even identifying potential issues. However, human testers bring critical thinking, creativity, and the ability to understand the context of the software being tested. They can also identify complex bugs that AI may struggle with. So, while AI may change the landscape of software testing, it is unlikely to replace human testers entirely.
Hello everyone, I hope you enjoyed the conversation between my AI clone and the AI bot. I'm Geosley Andrades, Director Product Evangelist at ExcelQ, and I lead the Q community, which is a global community of test automation enthusiasts. I have in all 15 years of experience. I'm a tester by heart and driven by community. Today we'll talk about unveiling the wizardry, decoding the magic of AI in testing. So before we get started, let's look at what is artificial intelligence. Artificial intelligence is the science of making machines do things that would require intelligence if done by humans. So let's look at the evolution of testing. This is from the source of Gartner. You can see in 1980s, we had a lot of manual testing that was done. Then it evolved into early test automation in 1990s, then browser automation frameworks, and eventually continuous testing frameworks, and then in 2020s, AI augmented testing. With this evolution, we are able to reduce the delivery cycle time considerably, and that's where the use of AI has allowed us to increase our testing efficiency. In today's talk, we will be talking about the application of AI in testing. I'll be covering 4 different scenarios. Definitely there are a lot more, but we'll pick a handful of them. So the first is discover new test. Second is action logic creation. Third, visual testing. And fourth, test data creation. So let's look at the first application of testing, which is discovering new test. Traditionally, discovering new test was done using exploration, and for which we use something similar to a test plan template, where we had written the expected result and the actual result. Now, modern ways of how this application has changed with the use of AI and discovery of new test is specifically using spidering AI. Now you can see this application where it is crawling through the entire website across different elements on the screen and evaluating the various actions it needs to perform and checking whether they are working as expected. If you're interested in this project, which is Agent, AI Generation and Exploration Test, you can refer the GitHub link down below. Now what is happening behind the scenes is it's training something called as the neural network model. The sequence of how a neural network model is trained is using 3 steps. The first step is perceive, which is perceiving the environment, drawing observations, planning possible actions. So if you're looking at a login screen, you perceive that on the page there are login screen elements. The next step that happens is act, which is select actions and execute. So in this case, say our action is clicking on sign in button. And the third step on training of neural network is observe. The moment you sign in, what do you see? What are the observations that you see? Do you see any error messages? So something like you enter a blank username and a password, you should see an error message. If you enter the correct username and password, you should be able to log in into the platform. So this is how the neural networks are trained. Now we're looking a lot at generative AI tools that have come up in the market, and here's an example of Bard which we are using right now for test case generation. So I give it a prompt to write a set of test cases to test a banking application with 4 modules, namely login, update user information, and perform funds transfer and view account summary. So on Bard, it was interestingly able to give me the various modules, the positive and the negative test cases as well, very easily and attractively. One thing I found out is that obviously the test cases that it generated are not very exhaustive as we expect as a tester, but definitely it's a good starting point. One thing I was surprised is that it gave additional tips of how to write different test cases, which was definitely something very helpful. Let's look at the second application of testing, which is action logic creation. Traditionally, action logic creation, you needed to write tons and tons of code. Now, this is a simple example of a login screen where you need to import the web driver, you need to access the URLs, enter the username, passwords, and then click on sign in. In order to do this as well, you need to be aware of locators, what sort of locators you need to use, and it was very complex. In modern days with the application of AI, you can write those lines of code using natural English language. A similar login screen would look something like what you can do in this 3 lines shown here, which is entering the username, entering the password, and clicking on sign in button. Now here we are going to give and see an example of sentence similarity and how the algorithms are applied to make sure that what you're typing is what the application should interpret. So this is a simple sentence similarity demo where I am importing the necessary modules. I'm defining these sentences that I need to compare. So, and then I'm using the model or the AI LLM model which I need to use to identify the sentences are similar. I'm going to compute the embedding for both the sentences. I'm going to compute the cosine similarity. How similar are these sentences? So in the first step, we are going with I am happy and I am happy as the sentence. And here we are going to figure out what is the cosine similarity score for this, right? So I'm typing Python sentence similarity.py. And here we are going to figure out and expect that the semantic similarity score is 1.0, which is the highest. So they are exactly similar. Now I'm just trying to change the sentence a bit now. I'm going to say I'm happy and I'm full of happiness. These are the two sentences we want to compare. And now we're going to run the same program and you can see here the sentence similarity score has reduced a bit, which is 0.60. So this is how applications understand what you're trying to interrupt and then behind invoke different actions that it needs to perform. What's happening behind the scenes? It is using natural language processing, which is divided into two parts, which is NLU and NLG. NLU is divided into lexical ambiguity, which means that a word can carry different sense. Syntaxical ambiguity, which means you can have more meaning for a sequence of words, and referential ambiguity if a word entity repeats itself again. And of course, there is natural language generation where you have to do text planning, sentence planning, and text realization. Here we are going to take an example of cursor.sh for test code generation. So I've given this a prompt, which is write a code in Selenium Python that opens Google in Firefox browser and searches for AI in testing and waits for 3 seconds. Now cursor.sh is a very powerful tool. So give the same prompt in this particular platform and you will see that it is able to generate this particular piece of code for us. So within a matter of seconds, the generative AI model has already given you the code. You do not need to scratch your brains at all. So once this code is generated, we are going to copy paste this particular piece of code in the same cursor.sh platform. And I'm going to run this particular thing to validate whether the code that was given to us was right or not. So here it opens the Firefox browser. It's going to go to Google. It's going to type AI in testing. It's going to search that. You can ignore the pop-ups for now because I have not handled that. And then it's going to search for AI in testing. So this is a very powerful tool which you can explore as well. One thing you need to realize is that even though AI is able to generate code for you in less minutes, you shouldn't be breaking your brains to debug or maintain this particular code. So be watchful of that. The third thing, which is visual testing. Traditionally, visual testing has been pixel to pixel comparisons. And there, even if an image moves slightly by a slight pixel, you will see false positives being generated. Traditionally as well, if you look at a screen which is having 20 visual elements and you got to write 5 assertions per element, you are writing 100 lines of assertion code. And when you multiply it with 30 different browsers and 100 different screens, you have to write 60,000 unique configurations. Now this is something very difficult to do. Modern days of AI and visual testing, you can within a matter of seconds be able to identify the difference. Now within these two images, it is very difficult for us to identify what the difference is. But with AI, you will be able to get this in seconds. Let's see an example of how this is done. So I am using here OpenCV and num.py, wherein I'm going to insert the exact two images that we saw earlier, which is the original image and the image to compare. I'm going to subtract and find out what actually is the difference. If the difference between the images is true, which means they are perfectly same, I'm going to output that the images are same. And if they are different, I want to pop out or find out what the differences actually are. From a visual standpoint, since I want to show you these images as well, once the difference comes out, I'm going to reduce the size of the images to 30% and I'm going to display that to you after the code is run. So let's run this particular test, which is Python visual testing.py, and now here you can see that the two images that we just compared and the difference as an output within seconds. So you can see here the time changed, like one is missing, the Falls Creek is missing, the spelling of Vancouver is wrong, the degree in 46 degree is missing, the scale 0 is missing. So what's happening behind the scenes is computer vision that is being used. Each pixel in the image is represented with values from 0 to 255. The complexity of it increases where values have to be stored for color images, which is stored again in RGB format. So each of these colors would have a different number associated with it. And this is how it assists in comparison. Let's talk about the fourth use case, which is test data generation. Traditionally, test data generation was done either using random classes in Java, jQuery APIs or other Faker.js APIs. Today, the modern ways of how AI generates test data is it learns from production data and then it's able to predict test data. Here we'll look at the film mask demo. I'm going to use the transformers library, which is again an open source AI library. And I'm going to use the model name Distill Roberts base. And I'm going to create a film mask pipeline. And I'm going to pass a sentence saying mask is the capital of France. So I'm expecting the AI algorithm to predict and tell me what this mask would be or what is the most likely value or data that this sentence can have. So I'm running python filmmask.py and let's wait for it to execute. And here you can see that the most likely comparison here is Paris is the capital of France. And it's kind of suggesting you that yes, this particular value is Paris. Now let's look at how we can use test data generation in ChatGPT. So I'm using the OpenAPI key and the model GPT 3.5 Turbo, and I'm asking it a question to tell me the name of top software testers in the world. I'm going to run the ChatGPT program, and here you can see it has generated the list of top testers in the world. This is the data which you can use in your respective automation or projects. So what is happening in the background? It is using generative adversarial networks, which is called GAN, G-A-N. And this generative model uses training samples. And then based on the input that you give, it's going to give you a generated sample. So in summary, what have we learned today? We have learned how we can discover new tests using training the network neural models, action logic creation using natural language processing, visual testing using computer vision, and test data generation using generative adversarial networks. In conclusion, we need to understand that AI is neither good nor evil. It's a tool. It's a technology for us to use. So my urge is to embrace AI and let's coexist to get and reap the highest benefits. In short, AI can enable humans to focus on parts of their roles that add most value. So thank you so much. I thank all of you for being with me, and you can connect with me on LinkedIn, Twitter, or YouTube for more questions regarding AI in testing. Namaste and enjoy the rest of the conference.